statisticshomeworksolver.com. For any help regarding statistics homework help, visit https://www.statisticshomeworksolver.com/ email support@statisticshomeworksolver.com or call us at +1 678 648 4277. 1. Suppose that. What is the PDF of x? 2. Find the transform of the random variable x with density function, where p is a constant with 0 less than or equal to p less than or equal to 1. 3. Consider random variable z with transform. Problem statisticshomeworksolver.com. A. Find the numerical value for the parameter a. B. Find p, z greater than or equal to 0.5. C. Find ez by using the probability distribution of z. D. Find ez by using the transform of z, and without explicity, using the probability distribution of z. E. Find var z by using the probability distribution of z. F. Find var z by using the transform of z, and without explicity, using the probability distribution of z. 4. A coin is tossed repeatedly, heads appearing with probability q on each toss. Let random variable t denote the number of tosses when a run of n consecutive heads has appeared for the first time. A. Show that the PMF for t can be expressed as. B. Determine the transform MT(S) associated with random variable t. C. Compute ET, the expectation of random variable t. 5. This problem is based on an example covered in Monday's lecture, Lecture 11. Let x and n be two independent normal random variables. Say x tilde operator n, 0, sigma 2x, and n tilde operator n, 0, sigma 2n. Let y equals x plus n. In lecture we saw that y is also normal. The lecture slides also prove that the conditional PDF fy, x, y, x is normal. statisticshomeworksolver.com. Tilde operator we saw that y is also normal. The lecture slides also prove that the conditional PDF fy, x, y, x is normal. Prove that for every value of y, the conditional density fx, y, x, y is normal. 6. 4 fair six-sided dice are rolled independently of each other. Let x1 be the sum of the numbers on the first and second dice, and x2 be the sum of the numbers on the third and fourth dice. Convolve the PMFs of the random variables x1 and x2 to find the probability that the outcomes of the 4 dice rolls sum to 8. 7. Consider two independent random variables x and y. Let fx, x, equals 1 minus x/2 for x is an element of 0, 2, and 0 otherwise. Let fy, y, equals 2 minus 2y for y is an element of 0, 1, and 0 otherwise. Give the PDF of w equals x plus y. G1. Let x1, x2, xn be drawn I.D from the uniform distribution on 0, 1. Let y be the minimum of the xi and let z be the maximum of the xi. Let w equals y plus z, compute fw, w, and prove that for all O0. Lim infinity p, w minus 1, o equals 0. Thus, for large n, with very high probability w is close to 1. statisticshomeworksolver.com. Solutions 1. X is the mixture of two exponential random variables with parameters 1 and 3, which are selected with probability 1/3 and 2/3, respectively. Hence, the PDF of x is 2x is a mixture of two exponential random variables, one with parameter lambda and one with parameter. We select the exponential with parameter lambda with probability p, so the transform 3. A. The definition of the transform is statisticshomeworksolver.com. B. We approach this problem by first finding the PDF of z using partial fraction expansion. statisticshomeworksolver.com. For A, since it is impossible to get a run of n heads with fewer than n tosses, it is clear that point k equals 0 for k less than n. In addition, the probability of getting n heads in n tosses is Qn, so point n equals Qn. Lastly, for k greater than or equal to n plus 1, we have t equals k if there is no run of n heads in the first k minus n minus 1 tosses, followed by a tail, followed by a run of n heads. So B, we use the PMF we obtained in the previous part to compute the moment generating function. Thus, we observe that the set of pairs I, k greater than or equal to n plus 1, I greater than or equal to k minus n, is equal to the set of pairs I greater than or equal to 1, n plus. StatisticsHomeworkSolver.com. We observe that the set of pairs I, k greater than or equal to n plus 1, I greater than or equal to k minus n, is equal to the set of pairs I greater than or equal to 1, n plus 1 less than or equal to k less than or equal to I plus n, so by reversing the order of the summations, we have StatisticsHomeworkSolver.com. Note that for n equals 1, this equation reduces to ET equals 1/q, which is the mean of a geometrically distributed random variable, as expected. 5. We calculate fx, y, x, y, using the definition of a conditional density. To find the density of y, recall that y is normal, so the mean and variance completely specify fy, y. Y equals x plus n, so y equals x plus n equals 0 plus 0 is equal to 0. Because x and n are independent, var y equals var x plus var n equals sigma 2x plus sigma 2n. So, StatisticsHomeworkSolver.com. We can simplify the exponent as follows. Thus, we obtain StatisticsHomeworkSolver.com. Looking at this formula, we see that the conditional density is normal with mean. 6. Let re be the number rolled on the ith die. Since each number is equally likely to rolled, the PMF of each re is uniformly distributed from 1 to 6. The PMF of x1 is obtained by convolving the PMFs of r1 and r2. Similarly, the PMF of x2 is obtained by convolving the PMFs of r3 and r4. x1 and x2 take on values from 2 to 12 and are independent and identically distributed random variables. The PMF of either one is given by StatisticsHomeworkSolver.com. Note that the sum x1 plus x2 takes on values from 4 to 24. The discrete convolution formula tells us that for n from 4 to 24. And thus we find the desired probability is 7. The PDF for x and y are as follows. StatisticsHomeworkSolver.com. Because x and y are independent and w equals x plus y, the PDF of w can be written as the convolution of fx, x, and fy, y. There are 5 ranges for w. 1. W less than or equal to 0. StatisticsHomeworkSolver.com. StatisticsHomeworkSolver.com. G1. To compute FW, W, we will start by computing the joint PDF FY, Z, YZ. Computing the joint density is quite simple. Define the joint CDF FY, Z, YZ equals P, Y less than or equal to Y, Z less than or equal to Z. Now, FZZ equals P, Z less than or equal to Z equals Zn, because the maximum is less than Z if and only if every one of the xi is less than Z, and all the xi are independent. We can also compute P, Y less than or equal to Y, Z less than or equal to Z, equals Z minus Y, n because the minimum is greater than Y and the maximum is less than Z if and only if every xi falls between Y and Z, subtraction gives. Now, we find the joint PDF by differentiating, which gives Fy, Z, YZ equals n minus 1, Z minus